Now let's talk about data transformation. Defining data transformation rules and storing them inside a local configuration file is workable when the source file with CDRs requires only trivial modification. For example, converting cents amounts into dollars or stripping initial zeros from the CLD. On your screen, you can see a small example for the case when you only need to build a proper value for H323 connect time field. The task was to build H323 connect time in the format that you see on your screen. That is basically used by the billing engine, using two fields from the source file, start date and start time. However, if you deal with complex data transformation rules that contain multiple subroutines or work with external modules, writing data transformation rules within a configuration file and managing the file itself can be a difficult task. At PortaOne, we recommend that you create custom modules and keep such complex data transformation rules within them. When you create such a module, you enjoy benefits such as syntax highlighting or auto-indentation. You also have advanced flexibility for working with files that are similar in nature, so that instead of copying and pasting existing code pieces, you simply create a new class that extends or overrides only some data transformation rules for the base class. Let's now talk about a scenario. Imagine that as PortaSwitch owner Telecom ABC, we have a service provider called Provider ABC that provides us with a source file with raw CDRs that we want to import into our PortaSwitch. The file with the raw CDRs will contain both voice, internet access, SMS and MMS services, so we'll need to distinguish between them somehow. On your screen you can see an example of the source file from Provider ABC that we are going to process. The end user accounts are named like you see on your screen. However, the portability accounts use a different naming scheme. So, to successfully import the source file, we'll need to convert the account names used by Provider ABC to account names that are used in portability. Finally, let's start with module programming. Let's start with the main module that will simply filter the source file with raw CDRs by services for further processing by individual per-service models for better code readability, usability, and troubleshooting. So let's go to the appropriate directory on the file server on the file system and create the appropriate directory for where we are going to store our custom data transformation modules. Okay, so as you can see in this module we have logic for filtering the source file with CDRs by service types. In case of voice pattern found in the appropriate field, we will launch a dedicated module for voice service processing, and the same applies to the internet access module. Let's save it. Now let's add a module that will add a transformation logic for attributes used in every service type. When possible, when you are composing parallel expressions, try to use subroutines. The only correct way to modify a field value is to return a new value from its method. A subroutine returns scalar, a new value for the field, or undef. In this case, the field is removed from the final record. So in this module, we process attributes that are common for all our service types, like for voice and for internet access service type. So we are making transformation of CLI into E164 format by stripping leading zeros and replacing them with 1. And we are doing the same for the username, and also we are adjusting the connect time. So let's just save this module. Now let's create separate module to handle CDRs per specific services. Okay, so you will almost always have some required field, for example, PortaOne service type, that is absent in the source file simply because your vendor knows nothing about this field. So we need to define this field and populate it with a constant value. To do this, use the constant method, and here is an example. Constant method, and we put voice pattern here. It's also possible to define a specific attribute as mandatory. For example, the billing engine can't create a CDR without username. So let's make sure that our mediator modules will send username, always send username. And also another example with H3 to 3 connect time, which is also mandatory. Also, in case of voice, we are going to import voice CDRs with a predefined charge amount. So we need to add override rate price attribute processing. Here it is. So we are calling a dedicated subroutine. We simply just check the field whether it's a zero value, and otherwise return the value. And our voice call CDRs will be charged with prices taken directly from the source file instead of rate-based charging. So let's save this. Let's also create a module to import internet access CDRs charged using rate pattern. Okay, so this is a module for net access CDRs. As you can see, username is also mandatory here. Event timestamp is also mandatory here. We are using constant to put the net access pattern, and we have a dedicated subroutine for rate pattern processing. So depending on the field in the source file, we return either net access 4G with rate pattern or net access 5G. Let's save this module. So for consistency, let's also create a module to import SMS service CDRs. So as you can see, again, constant, username and event timestamps are mandatory, and messaging CDRs will be charged during using different access codes. So we have a dedicated subroutine access code where we're going to apply different tariffs depending on the type of messaging type, so whether it's a SMS or MMS. We will basically return the appropriate access code. Let's save this module, and since this is a new service type that we decided to add, in the end, we also need to modify our main module. So let's open that file and add the appropriate part so we could handle the messaging type CDRs from our file that contains actually all services. And also So we will filter the lines in the source file by SMS, and when found, we will launch a dedicated custom module. So let's also save this file. Now, here is one more important thing to always keep in mind. After you make any changes in custom Perl modules, the appropriate xDR Mediator services should be manually restarted for those changes to take effect. Let's restart the xDR Mediator service and check the log that there are no errors after this restart. Okay, restarting. Let's check the status. Everything is fine, up and running. And let's check the log. So this is the indication of our last recent restart, and there are no new errors in this log, so everything is fine.